DNA is a code that holds all the information to make all living things. An instruction manual to make a worm or a cat or a fly or a human or a dinosaur. Its regularity, stability, reliability and predictability, even its relative boringness, make it the perfect system for storing the vast amount of information necessary for building life. Somehow, DNA must tell each and every cell in the body what it is to become and when and where. But how? 1950 scientists had a big job to do. They had to crack the code. So if you consider how a code works, let's think it out. We've got 4 bases, and we know that we need to make 20 different amino acids. So if we have a code that just consists of 1 base, we could only make 4 possible amino acids, right? Which isn't enough. So if we had a code that consisted of 2 bases that could get together in any combination, how many different amino acids could we make then? Yes. 16, exactly. It's not enough, is it? We need 20. So if we had a code based on 3 bases that could get together in any combination, how many amino acids could we produce then? 9, not quite, yeah. 64, exactly, more than 9 and more than we need. So 3 bases would work. And that's exactly what scientists found to be the case. They worked out the code, and they worked out that it was arranged in 3s, a triplet code, with each group of 3 bases called a codon. And each group of 3 bases or codon specifies or codes for a particular amino acid. So we can see that here. Here's a codon of 3 bases, and that will give us an amino acid, which we give another single letter code to. Okay, we needn't worry about the amino acid code for now. So here's another codon, CCC, that gives us this amino acid P. And here's another codon, GAA, that gives us that amino acid E. So we can start to decode this DNA sequence and turn it into an amino acid sequence. So we can see a growing amino acid chain in a protein. Now I'm not going to waste my time decoding all of that now. We've got one here that we prepared earlier. We know it's the same. This is all these nucleotides, all these codons decoded into these amino acids. So here is our protein chain. So a protein is like a sentence of amino acid letters. And you can even see that we've got some punctuation in our sentences, because it turns out that there are special codons that make something like a full stop at the end of the protein.